Good morning, everyone. Today we'll be exploring carbon credits and carbon capture utilization, two innovative approaches that help us tackle climate change. These strategies not only reduce harmful emissions but also open new doors for economic opportunities. What are carbon credits? So, what exactly are carbon credits? They are tradable permits where one credit equals the right to emit 1 metric ton of CO2 equivalent. The core idea is to create economic incentives for reducing emissions. Here's how the mechanism works. First, cap and trade systems set an overall limit on emissions. Companies either receive or purchase allowances to stay within that cap. If they don't need all their credits, they can trade them with their organizations. And through offsets, companies can also fund verified reduction projects like renewable energy or reforestation. In short, carbon credits turn climate responsibility into a measurable and marketable action. How carbon credits function. Now let's break down how the system actually functions. Emissions limits set. Governments Governments establish strict caps on the total emissions industries or regions are allowed to produce. This scarcity increases the value of reducing emissions. Credits allocated, companies receive an initial set of allowances, usually based on their historical emissions or industry benchmarks. Trading occurs. If a company goes over its limit, it must buy extra credits from others who have reduced their emissions and have a surplus. Projects generate offsets. Renewable energy plants, reforestation programs, and efficiency upgrades all generate verified credits that can be sold in the carbon market. This system ensures that companies either reduce emissions or pay for those who do. It's accountability in action.
So myself Tejas Shinte, roll number 23101 A0037. So the fourth slide is about carbon credit benefits. What make carbon credits powerful are their benefits. So the first benefit is green innovation. By pricing carbon, companies are pushed to adopt cleaner and more efficient technologies, making renewables and eco-friendly solutions more competitive. Second is financial incentives. Business that cut emissions can generate extra revenue by selling unused credits, while heavy emitters get a cost-effective compliance pathway. Third is corporate image. Beyond the numbers, being part of this system builds a company's reputation as an environmental leader, which is crucial for investors, customers, and stakeholders. So, carbon credits are not just a regular tool, they are a driver of innovation, profit, and reputation. So, the fifth slide is about carbon capture and utilization. Now, let's shift to carbon capture and utilization, or CCU, a revolutionary technology. Instead of letting CO2 escape into the atmosphere, CCU captures emission directly from industrial sources and transforms them into useful products. This creates a circular carbon economy where waste turns into value. The key advantage of CCU are first, it reduces atmospheric CO2 concentrations, directly fighting climate change. Second, it creates economical value from what making factories and power plants cleaner. And importantly, it supports the transition and net zero emission. In short, CCU makes carbon not just something to eliminate, but something to use.
Challenges and solutions. Of course, there are hurdles that we must overcome. The current challenges in these solutions include high capital and operational costs for CCU plants, energy-intensive capture processes that demand advanced technology, limited policy frameworks that don't fully support the large-scale adoption of such measures, and the need for stronger market development. But there are a lot of emerging solutions. A few of these are new technologies which are rapidly cutting costs, governments which are stepping in with incentives and bonuses for companies to adopt such environmentally friendly measures as CCUs, and the private sector, which is investing heavily in sustainable solutions. Finally, international cooperation frameworks are bringing nations together. So while the challenges are real, the solutions are being developed faster than ever. Coming to the net zero 2050 vision. Let's look at a timeline for the net zero 2050 vision. By 2025, first generation CCU technologies will be commercially deployed, supported by governments and early adopters. By 2035, CCU will become cost competitive with traditional methods, leading to widespread adoption across industries. And by 2050, we expect an integrated global carbon management system where net carbon credits and CCU together achieve net zero emissions at scale. This timeline shows that achieving net zero is not just an idea, it's a very realistic and possible pathway.
Carbon capture technologies help reduce emission by trapping CO2 at different stages. Pre-combustion removes CO2 before burning. Post-combustion captures it from flue gases. And oxygen fuel combustion burns fuel in pure oxygen to create easier to capture CO2 steps. Once captured, this carbon can be reused. Applications include many synthetic fuels like methanol and jet fuels, producing chemical and plastic, creating sustainable building materials, and even enhancing oil recovery while storing CO2 underground. Together, these solutions cut emission and turn waste into valuable